Hi class, today I have a sub. Today we're going to learn about rates and ratios, but first I want you to write down your answers for the starter. So let's go ahead and click pause while you try number 1, 2, and 3 on your own. In a second we'll do shoulder partner share and then reveal our answers. So let's click pause. Awesome. Hopefully you had a chance to work on problems 1, 2, and 3. High five your shoulder partner and say, I'm so glad you're in school today. Reveal your answers for both 1, 2, and 3. Go! Okay, go ahead and click pause if we're still not done. All right, let's go over our answers. This is our instructions just right here, simplify. And remember we talked about in Unit 2, simplify means find equivalent expressions. So we're finding parts that mean the same thing as this. So what parts or what expression is the same thing as 75 over 100? When we simplify, we're going to divide the numerator and the denominator by the same number. So I realize that 75 and 100 have 25 in common. So I'm going to divide both the numerator and denominator by 25. So I get 3 over 4. Now we can double check that on our calculator by using our ABC button. Anytime we need an extra practice, it's good to double check our answers. Same thing with number 2. So I'm trying to break this down into smaller parts, equivalent expressions. So it looks like 16 and 24 both have 8 in common. So I'm dividing the numerator and denominator by 8. So I get 2/3 as my answer. Now in chapter 3, I'm expecting that work to be shown. So I'm going to circle this right here and circle this right here. This is what chapter 3 is about. Finding equivalent expressions, or basically simplifying ratios. All right, let's do a quick chapter 2 review. When I see a -15, I need a +15. When that happens, I'm going to cross that off and I'm left with 2x, but I need to keep the equation balanced. So if I add 15 on one side, I'm going to add 15 on the other. And I get 12. Looks like I have 2 multiplied by x. The inverse of multiplication is division. I'm going to cross off that 2, and I'm left with x equals 6. Nice job. So right now, double check you have 3/4, 2/3, and x equals 6 on your paper. Awesome. Alrighty, go ahead and get out your planners right now. I want you to write unit rates and ratios. Those are 2 main things that we're going to be talking in chapter 3. And I also want to make sure that you have a worksheet. So please go ahead and pause the video. I want you to make sure this is in your planners because it's important to keep organized what we're learning and what's our expectation for today. So please write that down. Wonderful. Today we're going to go ahead and skip our flashcards. That's just because we have a sub today, so we will return flashcards when I get back. Alrighty, so these are our notes for today, Those are our notes for today, and we want to get those out and make sure we understand our key vocabulary. And our key vocabulary today is ratios. So let's go ahead and learn what a ratio is. A ratio is a comparison of 2 quantities, such as A to B, or A to B. And you're like, wait a second, you keep on saying A to B. Well, that's true. That's how all of those expressions right there are verbally said out loud. So that's how we say our ratios. In fact, we should put ratios right in the middle there. Now, I know some of you guys are like, what is she even talking about? Let's give some examples. So let's go back into my childhood. I know Halloween is coming up, so let's think of an example of Halloween. When me and my brother were younger, we were competitive on the number of candies that we would get compared to each other. So we're going to pretend like my brother had 15 M&Ms. He is so awesome, and I only have 7 M&Ms. So we're making a comparison right now. His M&Ms versus my M&Ms. That is a ratio right there because we are making a comparison of two quantities. In fact, let's go ahead and put a little number sign next to quantities. That's just a big word that basically means numbers. We're comparing numbers. Let's kind of go off to the side here because I know you've been comparing numbers in your science class. So let's look at the molecule H2O. In this problem, in this molecule, we have 2 hydrogens compared to our 1 oxygen. And we can write this a couple different ways. We can write it like 2 to 1, 2 over 1, which is 2 to 1, or we can literally write 2 to 1. Those are the 3 different ways we can write a ratio. Let's look at another one. Let's look at methane. We have 1 carbon to 2 hydrogens. So 1 carbon to 4 hydrogens. So our ratio is 1 to 4, 1 to 4, or 1 to 4. Those are examples right there. And you can do the same thing with silica or any kind of molecules. I know glucose is a 1 to 2 to 1 ratio, but we're only focusing on ratios that have 2 numbers. Okay, so let's go back in our example here, back to our notes. In fact, let's go ahead and move that over. And I'm going to go ahead and write down molecules because those truly are ratios. Let's look at some non-examples. Like for example, if you're saying 15 M&Ms, that's not an example because we're not making a comparison. We're just saying 15 M&Ms. That doesn't help us. Now let's look at our sentence here. I use a to compare the I have to the number of shirts I have. Well, let's fill in those blanks. I used a ratio to compare the number of pants I have to the number of shirts I have. So let's say you have lots of clothes. You have 20 pairs of pants. Oh my gosh, so many pairs of clothes. If you have lots of pants, I'm guessing you have tons of shirts as well. So let's say you have 50 shirts. You just have a closet full of stuff. This is a ratio. We're comparing the number of pants we have to the comparison to the number of shirts we have. That is a ratio. Now, I know some of you guys are thinking, well, wait a second. We had the same number, or excuse me, the same label on M&Ms. Can we have different labels, pants and shirts? Yes. We can have different labels. We can have the same labels, which is M&Ms over here, or different labels, pants and shirts over here. Same thing with our molecules. Hydrogen is different than oxygen, but that's still a ratio. So let's talk about some examples that we have. So a comparison, I guess I should zoom in here. Let's zoom in. A ratio is a comparison. So go ahead and write that down. A comparison of 2 quantities. So we're comparing 2 numbers. Number versus another number. Doesn't matter what those numbers are. And a rate is a ratio with different units. So on this one, it would be a great idea to write down pants versus shirts, or oxygen versus hydrogen. Those are different units, basically meaning different labels. And if you want to write down labels as well, that would be fine. Those are 2 different labels. They're different. Now unit rate is a little bit different. A unit rate is a rate with a denominator of 1. So let's write that down. A denominator of 1. So those are the different ways, or the different types of definitions that we're going to have today. So we have ratios, which are rates, and rates are also unit rates. Another graphic that we can do is a circle diagram. So here we have ratios, and there's specific ratios called rates, and there's even more specific rates called unit rates. They're all part of the same family. And that's exactly what this diagram, I keep on making lines, sorry guys. That's what this diagram right here is saying. We have ratios, that's our big family, but ratios are rates, and more specifically, rates are unit rates. So let's talk about some examples of these, because I know it kind of gets confusing. So ratios is a comparison of quantities. So let's write down 15 M&Ms compared to the 7 M&Ms. Now, rates, we need two different labels or two different units. So let's say we are buying pumpkins since it is Halloween time. And we're buying 2 pumpkins for $8. These have two different units. On the top I have dollars, and on the bottom I have pumpkins. So dollars is different than pumpkins. But ratios, it's okay to have the same label on the top. M&Ms and M&Ms. This is still a comparison no matter if they're the same or different. Now unit rates, we're going to still use that pumpkin example. Each pumpkin in the example above was $4. So we still have different labels on the top, or different units, but our denominator is 1. That's exactly what that says. Unit rates have to have a denominator of 1. Awesome, guys. Let's make sure you have that on your notes. All right, so let's go ahead and turn our notes over and let's get to the important problems that we're going to have on our homework tonight, as well as problems you're going to see on the assessments. Let's make sure you are ready to see different types of problems. So the first one says, write the ratio as a fraction in simplest form. I'm going to go ahead and circle fraction because that's important, and I'm also going to circle simplest form. That tells me we're going to simplify. So first thing is I need to take this ratio and I need to turn it into a fraction. So 5 goes on the top and 25 goes on the bottom. We need to simplify just like what we did on our starter. So 5 and 25, looks like those both have 5 in common. So I'm going to be dividing by 5 over 5. Now remember, I'm not changing the quantity at all. I'm not changing what this number is because I'm essentially dividing by 1. So my numerator is 1 and my denominator is 5. There's no label on this problem because there's no label right next to that 5 or a label next to that 25. So my final answer is 1 over 5. Okay, go ahead and pause the video if you need to. Talk to the sub. I want us to try number 2 with a partner. High five your shoulder partner and say, let's do number 2 together. Awesome. I want you to pause the video and try number 2 on your own. Go. All right, let's see how you did. So looks like we're going to follow the exact same instructions as our problem we did on number 1. So we're going to go ahead and take it and put it as a fraction. So we're going to have 24 on the top and 6 on the bottom. Now we need to simplify just like we did on the starter. 24 and 6, they both have 6 in common. So we're going to get 4 as our numerator and 1 as our denominator. Now let's go ahead and talk about a mistake a lot of people are going to make. They're just going to leave the answer as plain old 4. And let's talk about why it's not just plain old 4. We are making a comparison between mummies and Frankensteins. We still need to know how many Frankensteins we have and how many mummies we have. So we're going to put 4 mummies on the top and 1 Frankenstein on the bottom. And that makes sense because if we just put 4, we don't know how many mummies we have and we don't know how many Frankensteins we have. But if we make that nice fraction, we definitely know. Okay, awesome. I want you to try number 3 by yourself. So let's pause that video and try number 3. Go. Alrighty, let's see how you did. I hope that you have 18 as our numerator and 10 as our denominator. And we're going to simplify, it looks like by 2. So it looks like I'm getting 9 over 5. Now just on the top, we mentioned that we have mummies and Frankensteins. We're going to follow that same procedure and put ghouls and witches on our fraction because we need to have that label there. We're making a comparison between the number of ghouls we have and the number of witches that we have. It's a 9 to 5 ratio. Now let's have a real quick conversation about 18 over 10. Let's go off to the side. So if we have 18 to 10, some people on this test or maybe even on the homework are going to write down that the final answer is 1 4/5. We know that can't be the answer because that's not really a comparison. You might say, okay, we have 4 ghouls to maybe 5 witches, but where does the 1 go? That's kind of the question there. Does the 1 go with the ghouls? Does the 1 go with the witches? Someone might even put the 1 and now convert it into a 14. So just so remember, guys, we don't want to put it as an improper fraction, or excuse me, a mixed number. Let's repeat that. We don't want it as a mixed number, so I don't want to see this. I want to see a fraction as an improper fraction. So if you do get 1 4/5, we just need to change it into an improper fraction. So we're going to go 5 times 1, that's 5, and then we're going to plus that 4, and we're going to get 9. 9 is our numerator, and remember that the 5 just goes straight over. So our final answer is 9/5. If we have a label, which we do, we are going to write that down. 9 ghouls versus our 5 witches. And that's exactly what, sorry, I moved that over. And that's exactly what we have on our paper, right here. So make sure that's on your paper as well. All right, the last part of the notes is unit rate. Unit rate is a little bit different only because the unit rate needs to have a denominator of 1. Let's talk about what I'm meaning here. So we're still going to get 15 over 3, but this time, instead of simplifying, we are going to divide by whatever our denominator is. So we are going to divide by 3 over 3. Our denominator is 1. Our numerator is 5. Now I really want to talk about something mathematicians do. They have unit rates in a specific format. So they go blank per blank. I want you to write that down in your notes right now. So I'm going to pause just for a second and write that down. So this unit rate, we're going to put it in a specific format. We're going to write down 5 houses, because of course we still need our label, per hour. This is the correct answer. So again, this is close. This is wonderful work. I would still give you 50%. Half of the answer is correct. Awesome. But we need to have it in that special per format. So we go 5 houses per hour. That's how we know the final answer is correct. Alrighty, I want you to turn to your face partner and say, let's do number 2. Alright, pause the video. I want you to try number 2 with your shoulder partner. Okay, now we're ready for our game. It is called Quiz Trade. It's super easy, but I need you to pay attention since we've never played this game before. So what you're going to do, step number 1, is we need you to get your cards. So Seb, let's go ahead and pass out the orange cards. Everyone is going to need one. Step number 2, you are going to find a partner, and you're going to give them some kind of greeting. If you want to say hello, I'm glad you're my partner, whatever, but I need you to have a greeting. Step number 2 is someone is going to need to start the game. So you're going to start quizzing your partner. So A's, let's go ahead and have you quiz. B's, you're going to answer. And then A's, at the end, I need you to check or coach, because some of these questions are super hard. So A, if you have a tough question, I really do need you to be a leader on that and coach. The 4th step is that we are going to switch roles. So now the quiz, B, you're going to be doing the quizzing. A, you are going to be doing the answering. And B, you are going to check your answer, and all the answers are on the back of the card, or coach. If you have a tough one, be a leader for me. 5 is you're going to trade cards. So you are now getting a new card in the process. The last step is you are going to repeat these steps. You're going to find a new partner. So within like 5 minutes, you should have talked to at least 5 people, maybe even more. So let's go ahead and pause the video. I want us to go through the instructions with the sub. Make sure you really understand how we play the game because this can get really chaotic. So go ahead and pause the video. Alrighty, looks like you're ready to play the game. At the end, remember we do have homework. It is that worksheet. So at the end, make sure you do ask for your worksheet because I will be expecting that to be done tomorrow and I don't want to hand out any zap tickets. So please get that homework completed so I do not need to zap you. Please bring your questions and comments tomorrow. We will begin our session with any questions that you had from today. All right, be good, guys. Bye.